To our video, and we're going to share with you an explanation about stress in mechanics of material. Okay, so first let's take a look at the definition of stress. Stress is actually the strength of the material, and we're going to deal with two different stresses: normal stress, sigma, and also the shear stress, tau. Okay, so what is normal stress and what is shear stress? Okay, let's take a look at this Cartesian plane and imagine if we have a box here. So the normal stress is actually the stress acting normal on the surface. So you consider this surface, and the normal stress, sigma, acts here in the z direction, normal to the surface. And then the shear stress is actually the stress acting tangent to the surface, horizontally. So we have tau y in the y direction and also tau x in the x direction. Okay, so how are we going to calculate the normal stress and the shear stress? Okay, moving on to the calculation, we use the formula sigma P over A to calculate the average normal stress, and P is the normal force divided by the surface area. Then to find the shear stress, we use this formula T equal to V over A, and V represent the shear force and A represent the surface area. Find the average normal stress and the average shear stress along a section 15 degrees from the horizontal. So we want to find the normal stress and also the shear stress. So given 15 degrees, 3 inches at the height, the width is 1 inch, and also the force 85 pounds. So we want to find what is the normal stress and the shear stress at this surface along this section. So we need to set up the coordinate system. So we consider this one the x direction, and this one perpendicular to the surface, normal to the surface, y direction. For shear force, this one and this one is the normal force. So let's see the equilibrium equation to find the shear force along the x direction. V plus 85 cos 15, then we get negative 82.1 pounds. This one is negative, so since this one acts upwards, so the real one acts downwards, 82.1 pounds downwards since it is negative. So now let's see the normal force along the y direction, and minus 85 sine 15, and we get positive 22 pounds. So since this one is positive, so this direction and this direction remain unchanged. So we already have the shear force and the normal force. So now let's calculate the average normal stress and the average shear stress, but we don't have the area. So before that, we need to find this length first. So before we can find the area, we use trigo. Sine 15 equal to 3 over L. So we get the length 11.59 inch. So what we have to do is just multiply by the width, just now 1 inch. So we get 11.59 inches square for the area. So just insert this number into this formula to find the average normal stress, 22 divided by 11.59, and then we'll get 1.9 pound per inch squared for the average normal stress. For the average shear stress, 82.1 pounds divided by 11.59 inches square, and we get 7.08 pounds per inch square. Okay, so done with the example, we move on to the allowable stress design. Okay, so what is it? When we're building a structure or any mechanical element, the load applied has to be less than the load the element can fully support. If the load is too big for the element to support, then the structure will fail. So that's why we use a method called factor of safety. And using this formula, it is actually the ratio of failure load to the allowable load. So this one is the ratio of failure load, and this one is the ratio.
Now we're gonna have to solve this problem related to shear stress and normal stress. Here the problem. Figure 1 shows a speaker hang onto the wall with the steel rod. Here is the rod and this is the speaker. The rod has a length of 1.2 meter and the mass of the speaker is 5 kg. Determine the stress at point A if the length between point A and speaker is 1 meter, given the diameter and the mass of rod is 0.06 meter and 2 kg per meter. Okay, first step what we're gonna do is to redraw the force acting on the rod. Here we have uniform load for the mass of rod, which is 2 kilogram per meter. Here, you can see. Okay, now at here we have 5 kilogram. We need to find the weight of rod and the weight of speaker. The weight of rod is 2 kilogram times with the length of the rod is 1.2 meter here, and times with the gravity 9.81, and we get 23.544 Newton. Same goes to the speaker. Weight of speaker 5 kilograms times with gravity 9.81, then we get 49.05 Newton. Okay, now we need to know the location of the point load of the rod, which is in the middle. The middle is the length of rod in the middle is 0.6 here and 0.6 here, and the point A is here. Point A to the speaker is 1 meter, and the left here is 0.2 meter. Weight here 49.05 Newton and 23.544 Newton. Stop. 3. Okay, next we need to cut at A and calculate the force acting at this segment, which is we get here the cutting. Here is 49.05 Newton and here is 23.544 Newton. The length here between A and the point load here is 0.4, and here is 1 meter, 0.6. Okay, next we need to find the reaction. Here we have the Y direction, in the X, and the moment. Okay, now we have to find the X first. The summation of force in X direction is 0 in equilibrium. Since there is no force acting in X direction, we can assume the N is equal to 0 Newton. Then we find the Y, positive, equal to 0. V minus 23.544 minus 49.05 equal to 0. And then we get the value of V is 72.644 Newton. And then we find the moment. We take anti-clockwise positive, equal to 0. M minus 23.544 times with 0.4 minus 49.05 times with 1. Then we get 58.49 Newton per meter. Then we can substitute into the formula. This is a normal stress formula. N over A. N is X. Force acting is in X direction. And shear stress tau equal to V over A. Okay, first we need to find the area of the rod. We know the rod is in circular shape. So given the rod diameter is 0.06, then we can find the formula. Into the formula here, pi d square over 4. pi times 0.06 of diameter square over 4. Then we get 9 times 10 to the power of negative 4 pi m square. Then only we can substitute into the both of this formula. The normal stress we get, since the n is 0, then the normal stress is 0 Newton per meter square or Pascal. Then we can find the shear stress. We have V here, 72.644 Newton, 4 Newton, divided by the area, 9 times 10 to the power of negative 4 pi. Then we get 25.692 kilonewton per meter. This is the final answer. Thank you.